Hi, I'll be going over 9.10 rates of change, example 31. So the question says, in the decay of radioactive particles, so that's important, it says decay, so that means it's going down. The rate at which particles decay is proportional to the number of particles remaining. So the first thing I would do is I'd decide what letter I'm going to use. So I'm going to let n be the number of particles. The rate of change will be dn by dt. It says that that is proportional to the number of particles. So that is proportional to n. Write down a differential equation for the rate of change of the number of particles. So, if you remember when you did proportion previously, you would say something like x is proportional to y. So x equals ky. Exactly the same here. So we're going to say that dn by dt is proportional to kn. The important bit here is, and this might catch people out, it is going to be negative because it is going down. It is decreasing because of the word decay in the question. That is what you're going to have to be really careful at with these questions, is reading them carefully to make sure that you have understood what the question is. So that was example 31. Example 32. And again, we need to read it carefully. It says Newton's law of cooling states that the rate of loss of temperature of a body is proportional to the excess temperature of the body over its surroundings. So it's cooling, so it's going down again, so we're going to have a negative there. So we're going to say that the temperature of the body, and I'm just going to use the variables that they've used in the book, but obviously as long as it makes sense you could use whatever you wanted, is theta degrees at the time t seconds. The difference in the temperature will be the theta minus whatever the other temperature is. So they've done it with a theta with a little 0 there. Again, your notation could be slightly different. It might lead you in the question to what notation to use, but as long as it's consistent, you will be absolutely fine. So it said that it was proportional to the excess temperature. Well, that's the excess temperature. So we have got d theta by dt equals, so it is that, as we said before with proportion, we times that by k, and it is negative because it is decreasing. So just be consistent with your notation. As long as you're consistent with your notation, you'll be absolutely fine.